So here we go. I'm going to get you at least started with inequalities and everything, and I'll try to graph one, and the other ones will be for you to try at home. Okay? So here we have two or more inequalities. I won't do more than three. Okay, three is where we're going to kind of put a stop to this. Maybe a homework question might have a 4 inequality scenario. I will also, yeah, the one actually you were working on page 50, that one also has 4. So it gets kind of tricky, but if you're good with up to 3, you should be fine. Okay, so here we go. Let's write this down so we have a good example in our notes. Okay, so define variables. We're going to do that first. We're going to let x be the number of cakes A. Y would be the number of cakes of type B, and our implicit constraint, right, that's B here. We're just going to make sure everything is greater than or equal to 0 here. And now we're going to write our inequalities. Okay. So the first inequality here, in my opinion, is the fact that you have 50 kilograms of flour available. So that's IQ number 1, inequality number 1. So we use 150 grams of for cake A, and we use 75 grams for cake B, and that has to be less than or equal to the 50 kilograms, which is 50,000 grams, right? I'm just going to quickly do the 50 kilograms. 1 kilogram has 1,000 grams. Cancel that out. That's 50,000, okay, that you're allowed to use. So you want everything in grams. Okay, could you have converted the grams to kilograms and kept the 50? Yes, you could have. Just make sure you don't round. You use all decimals. Okay, so this is inequality number 1. I'll call that inequality 1. In order to profit, the bakery needs to produce at least 500 cakes combined. So if I put combined there for you right now, but on the test, you will just assume that that's the case. I'm not saying just one or the other. It's just 500 cakes, right? So that's IQ number 2. So we're going to go x plus y. That has to be at least 500. This is IQ number 2. This is a restriction on the number of cakes. What's the first one a restriction for? The amount of flour, right, that you have. The amount of cakes. And then there's another one. You make at least 100 of cake A. Okay, this is IQ inequality number 3. So it's particularly specifically just talking about cake A, and that has to be at least 100. Okay. Let the marks tell you how many inequalities there are. If it's a 4-mark question, 4 inequalities, right? And so forth. All right, now let's sketch this. Okay. Can I just say, I'm just going to say, this one talks about flour. This one talks about number of cakes. This one is number of cakes type A. Right? So those are the restrictions that each of them is trying to. And so every inequality you add, it gives you less and less of a solution region. It shrinks it. Okay. So graph them. Let's do that. I'm going to do this one here. 150x plus 75y is less than or equal to 50,000. And for this part, just copy this down. Just fast forward because you know already how to do the intercepts. I'm not going to spend too much time on that. So try to copy this as quick as you can because I want to get to the graphing part. This gives you 333.33, and remember that's only for graphing purposes, so we know approximately where to place that point. For the y-intercept, 75y is equal to 50,000. and y gives you 666.67. So that's 0.67. So this is just for graphing purposes. So I approach it the same way as before. Okay. Let's rewrite it. Please let me know if I'm off my margins. Okay, I'm going to try my best to stay in line here. 75y is less than or equal to negative 150x plus 50,000. The numbers can be big. It doesn't matter. We will not worry about that. Y is less than or equal to. You know what? This one actually, 150 divided by 75 is 2. So it's negative 2. And here, watch this, because this is going to go into your calculator later on, and you get a non-finite decimal, right? So I'm just going to keep it like that. Just keep it like that. This is solid. True region is below, but this is a system. We're going to do reverse shading, so we're going to shade above the line. Okay, let's keep going. No time to waste. This is the easiest one to do for intercepts, all right? You're going to love this one. X-intercept, Y-intercept, we know it's 500, correct? So it's just X is equal to 500, Y is equal to 500. So it's 500, 0, 0, 500. And rewriting it is a piece of cake as well. Maybe you don't like cake. It's a piece of fill in the blank. Right? Piece of donut. Anyways. Minus X plus 500. I don't know if you're going to notice that 99.9% of the lines are going to be solid. There may be here and there where I say more than, right? Or something that you have a dash, but you can kind of just assume it's always going to be solid. Solid, true region is above the line. We're going to shade below the line. Perfect. The last one is pretty easy. This one, it's a special, right? Vertical. Vertical line. So we just know that the x-intercept is 100, 0. Right? This is going to be solid. True region is where? It's to the right. And because this is a system, we like to use reverse shading. So we're going to shade to the left. So this is where being very fluent, right, practicing these at home will allow you to do this on a timely fashion, right? If you know what needs to be done, sometimes you want to do the work all on the left because I have a grid here. So just use your space wisely. Okay. Let's sketch this now. So I'm going to grab a ruler. And you make it fit your space, right? I'm going to use the corner here to graph this. This is cake B, and this is cake A. And you need to tell me what the units are. Number of, okay? Because it could be, the units could differ. So I hope you can see this. What is my scale? You need to make sure, look at the X, 333, 500, right? So you need to make sure you have enough room for that. So I'm going to use a scale of 100. So watch this. 100, 200, 300, 400, 500, and 600. It's probably a good idea to go a little bit above. And the intercepts allow me to come up with that. My y, it goes as high as 666. So I'm going to use the same scale going up the y, all right? So 100, 200, 300. Just try to make it, space it out equally to the best of your ability, okay? So 100. Oh, I think I may have, this is not going to be quite enough. So I'm going to fix this. It may happen to you. I think we're just going to make that 700 up there. I will probably give you a grid anyways, so you're going to be able to lay it out nicely. Okay, I've got my scale, I've got labels on the axes, let's go, right? 333 is right about there. 666 is right about there. I'm going to graph that. And students have, I find it a good idea to go off like this and just label it a little bit to the side. Okay, that's fine. That's the first one. The second one is 500s, right? In the 500s, either way, 500, 0, 0, 500, connect that. This is the line x plus y is greater than or equal to 500. One more. It's the vertical going through 100. Goes like this. This one, you can put an arrow head at the end here at the top. It's okay to continue that way, but do not exceed with your diagonals. Do not go outside quadrant 1. Okay, so this is x is greater than or equal to 100. And now it's the shading part. I should write that down first. You got this, guys. It's just be meticulous. Just be careful. Okay. All right, let's shade. I'm going to start with a vertical line, so shade to the left of it. Everything to the left. There we go. This line, x plus y, shades below. So just got to make sure you find it. That's why labeling it is very important. It's this one right here. I'm shading below that one. So everything below that line is gone. It's not an option anymore. So that's why every inequality restricts your solution region even more. Okay. And the last one is shading above. Right? If you shade everything, you're in trouble. Right? Okay, so I take that last one here, I shade above it. And you gotta be light, right? You don't wanna completely block out. There we go. There's a little sliver that remains unshaded, right? This one right here. So that is your solution region. Please write it in. I know it's small, but I made it happen. So this is all part of D, right? Graphing it. E, state a possible solution. We'll get to it in a minute. Let's go with F, the POIs. This is going to be worth quite a few marks, so you need to be able to do this properly, right? rewrite your inequalities and enter it into your calculator's properly. So let's go ahead and do that. Grab your calculator. 2 marks on the line here. So I'm going to go to y equals and enter one at a time. So this is negative 2x plus, watch this, right? That the y-intercept, I keep it as a fraction. Just enter it with brackets like that. And then you've got negative x plus 500. And then you've got, how do you graph a vertical line again? Do you remember that? Because otherwise, there's another way of doing it, but I like this one. So 9 nines. I don't think it matters. I think if you went more than 9, it's still going to be all right. But and what do you type in? X plus or minus 100? It's going to be minus 100. Okay. It's the opposite of what your x-intercept is. Okay. So you do that. My guess it's not going to be on our grid. So what? Let's try this. I don't see anything. Why is that? Oh, look at your intercepts, right? Your window. Okay. So window, my x max should be at least what my graph is on this paper. So let's go 600. And my y max should also be, I'm going to go to 700 with my y max. But always remember you have a little bit of a negative value here. Okay? For the x min and y min, it should be a bit of a negative. Hit graph. And there it is. And we know that this is my solution region right there, that little triangle. So let's go find those corner points surrounding it. So let's go second trace 5. You're on the blue line. So how about we find this one first between the blue and the red. So we're going to go enter. It jumps to the red one. That's perfect. Hit enter one more time. And then it's this. There it is. 166.67, 333.33. Okay, that's one of the intercepts. Let's find another one. Second trace 5, one more time. I'm on the blue line, I'm traveling, and I'm now going to focus on this one. So I hit enter on the blue. It jumps to the red. You want to jump to the black line. So I'm going to go arrow up until it turns into a black, everything turns black. Then hit enter, enter again. It's going to find that one. Okay? That one is 466.67. And if you're not getting it right now, part of your homework is to try to figure out these corner points. One more. Second trace 5. I'm going to jump to the red line. Right? Arrow up and down until you're red, because you want to find the intersection between the red and the black. So enter. As soon as I hit enter, it jumps to the black. That's what I want. Enter, enter. There it is. 100, 400. Okay. What's wrong with these points of intersection? Number of cakes. Can you have decimals? Maybe if you take a big bite off of it before you put it on the shelf, but that's not cool, right? So we round 167 to 333. This is 100 to 467. This one stays, right? So you just have to show me both. I want to see the decimal and I want to see the rounded version of it. So then you understand what needs to happen. I'm going to use a red pen for this following exercise here. Give me another possible solution. I'm going to go off of one of these points of intersection, okay? 100, 400 is where? It's this one right here. So I'm just going to say 101, 400, just a little bit off to the side. You could do 102, 400. But to be absolutely sure, you could plug it into all the inequalities and see if you get it right for all of them. Okay. Just so you understand, what are some options for this bakery based on all the restrictions? You can make 167 cakes of the type A cake, 333 of the type B cake. Okay. You can, like, these are your combos that you can use to fulfill all of the requirements of this bakery. Okay. All right. This is going to be your homework. Okay. So I hope this made sense. I want you to break this down into two components, right? So this is your homework. Page 50 all the way to, let me see, 54. And you're probably saying that's outrageous, right? I want you to write the inequalities first. Write the inequalities, then graph. So you write your inequalities, and when you think you got it, you're going to go check the key. When you double check that the key matches your inequalities, you put the key aside and you try to graph this thing. And then you look at the key again and see, oh, does my graph match the key? All right? Do at least 2 of them. Okay, at least 2, because it's going to be difficult. And so for you, it might take you 15 minutes per question, minimum. So half an hour, 45 minutes. Go through the process of, oh shoot, I got that sign wrong or whatever. Go through that so it sticks and you don't make that same mistake again. A lot of you did this on the whiteboard, so you kind of already know where to go with it. Okay? But it's very important. The only other thing after this, you're listening, right? The only other thing after this is to determine the best solution. That's the only other step. Other than that, this is where this is where it's ending. Okay? So what does that mean, Mr. Erickson? One of these corner points surrounding the solution region is going to be the best solution. It's going to be the ultimate, the one we want. Okay? That's going to come up next. So please do that. Watch this. One more thing. Oh no. Well, if you want more, 57 and 58 have QR codes. You can scan those, and it's a video of it. And the answer key of your solutions is actually on page 55 as well, for what you're doing as homework, if you want to double check. See you tomorrow, guys. Wednesday, right? +1.